He specifically said when it would be cold, i.e. after Christmas and February. We were right, they were wrong.
In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds. Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Nir Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compared the graphs, just put them one upon the other, and it was just amazing. Jan Weitzer looked at me and says, you know, we have very explosive data here.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun.
If you had X-ray eyes, what appears as a nice, friendly yellow ball would appear like a raging tiger. The sun is an incredibly violent beast, and it's throwing out great explosions and puffs of gas, an endless solar wind that's forever rushing past the Earth. We're, in a certain sense, inside the atmosphere of the sun. The intensity of its magnetic field more than doubled during the 20th century.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected, but now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.
To the Harvard astrophysicists and many other scientists, the conclusion is inescapable.
The sun is driving climate change. CO2 is irrelevant.
But why, if this is so, are we bombarded day after day with news items about man-made global warming? Why do so many people in the media and elsewhere regard it as an undisputed fact? To understand the power of global warming theory, we must tell the story of how it came about.
The weather satellite depicts a planet that grieves for its lost harvests in coming to the parched...
Doom-laden predictions about climate change are not new. In 1974, the BBC warned us of impending disasters which might seem strangely familiar.
Again and again, the newsreels have been showing us disasters of the weather. The American Midwest suffered its worst drought since the 1930s, and tornadoes were on the rampage.
And what was going to be the cause of these disasters? The man behind the series was former New Scientist editor Nigel Calder.
In the Weather Machine, we reported the mainstream opinion of the time, which was global cooling and the threat of a new ice age.
Nature's ice dwarfs us.
After 4 decades of falling temperatures, experts warned that a cooler world would have catastrophic consequences.
There's the ever-present threat of a big freeze. Will a new ice age claim our lands and bury our northern cities?
But amid the doom and gloom, there was one voice of hope. A Swedish scientist called Bert Bolin tentatively suggested that man-made carbon dioxide might help to warm the world, although he wasn't sure.
And there is a lot of oil, and there are vast amounts of coal left. We seem to be burning it with an ever-increasing rate. And if we go on doing this, in about 50 years' time, the climate may be a few degrees warmer than today. We just don't know.
We were also the first to put Bert Bolin of Sweden on international television talking about the